Hello guys, welcome to Degree Demons by 30 channel. In our channel, we have uploaded CSM5 full notes. From today, we are starting Physics M5. Our first topic is about Raman effect. It is an important question in a SEM5. It's a, at first, see what is the Raman effect. When a monochromatic beam of light is passing through a gaseous medium or a liquid medium or transparent solid, then the light undergoes scattering. Sir C.V. Raman is a scientist who propounded the Raman effect. He discovered Raman effect in 1930. He received Nobel Prize also. Okay, Nobel Prize. Sir C.V. Raman in 1930 observed that the spectrum of scattered light, in addition to the frequency of incident light, consists of frequency of incidence greater number of particles in a medium. This scattered light is fell on the particles contained in the medium, like smaller particles. Then the light is scattered through them. Okay. Scattered through them. This is the Raman effect. Let's see one more point is important. The spectrum of scattered light is called, the scattering light is known as a Raman spectrum. Okay, scattering light is known as a Raman spectrum. Then one more, it is seen like some lines. Okay, it is seen like some lines. Those lines called Raman lines, and they are also called stroke lines or anti-stroke lines. Stroke lines and anti-stroke lines. Stroke lines are of a higher frequency, anti-stroke lines are lower frequency. Okay, anti-stroke lines, stroke lines. The lines with the greater frequency are known as anti-stroke lines. Okay, next stroke lines. The lines with lower frequency are called stroke lines. Are called stroke lines. Okay, let's see the experimental arrangement of a Raman spectroscopy. Okay, experimental arrangement of Raman spectroscopy. Okay, the diagram of this experiment will be shown afterwards at this end of the video. Okay, you can take a screenshot from there. At first, let's see the steps. First one is scientist used wood operator. Scientist used scientists used wood operators to build these apparatus for experiment. Okay, these lines are enough. Let's see the next. As like we are using too many apparatus like for finishing the experiment, that process is enough for these points. It consists of glass tube, one glass tube filled with water. Okay, AB of length 10 to 15 centimeters, scientist use, and diameter 1 to 2 centimeter. It contains pure experimental sample. Contains pure experimental sample free from dust and soap bubbles. Okay, it is clearly visible that is filled in the glass tube. Okay, next the tube is closed at the tube is closed at one end by an optical plane glass plate, that is denoted W in that figure, and the other end it is drawn into a horn. Horn means like this, a horn of a cow, like that. In that shape he used. It is coated fully blackened. It is coated blackened outside. Okay, let's see the another steps. Okay, light from a mercury arc. Okay, next point, light from a mercury arc is passed through a filter F. Here a filter F is used, which allows only monochromatic light radiation. Radiation of lambda is equals to 4358 angstroms. Lambda is the wavelength, 4358 is the angstrom wavelength of a light to pass. Okay. Raman tube is surrounded by a water to which water is circulated to prevent overheating of liquid. Let's see right our fifth topic. Raman tube is surrounded by a water through which water is circulated to prevent overheating of the liquid. Okay, if a water is fully overheated, then the bubbles and vapors are coming out. To prevent that, Raman used the tube surrounded by water, okay, to prevent overheating that by circulating. This is the full explanation about Raman experiment. Let's see the Raman effect characteristics. Okay, Raman effect. Raman effect characteristics. Okay, in this first of the stroke lines are always more instance than anti-stroke lines. Okay, Raman and anti-stroke lines. The next is Raman lines are symmetrical in shape. Okay, if you divide both sides are same, symmetrically placed above the parent line. That means symmetrical means equal. Our third point is the frequency difference between the modified parent line represents the frequency of corresponding infrared absorption line. Okay, and let's see the stroke and anti-stroke lines. We forgot one point at the end of that experiment. Dark lines are formed. They are called stroke and anti-stroke lines. Okay, let's see the diagram of Let's see the diagram of experiment. Okay, at first it took a mercury. Okay, a mercury to measure the temperature. Okay, then he used one filter. Yeah, we discussed filter. Yeah, then he used two slits named R and it is a water filled the sample glass tube. Okay, it is over outflow water, overheated water, right side. We here horn, we discuss now only horn shape. It is fully blackened hilly blackened. It is horn. Here we forgot water intake. Okay, this is the water outlet, water intake inside. Okay, it is also filled with the liquid, and from here this is a scattered light of spectroscopy is seen here. Okay, from here on the satellite of spectroscopy, and here one more reflector is there, a R reflector. When the monochromatic light pass through a filter, it filters pass through these two slits, fall on this liquid and the sample, pure sample. When it scatters, we can see some scattered lines in this. Okay, scattered lines are shown on this reflector. Therefore, anti-stroke lines, lower frequency anti-stroke lines. Okay, have frequency mu lambda mu. Anti-stroke lines, frequency. These are stroke lines, strokes. These are normal. These are anti-stroke. Okay, this is the full information about the Raman effect. Hope you all understand this topic. Thank you.